All right, let's do it. All right, so welcome everyone. I'm seeing like a lot of familiar faces in the public. Hey, Dennis over there. But yeah, today I'm just going to be talking about Delta Lake and how you can use Delta Lake to build the next generation big data application. So let's just first start by looking at the agenda. So the first part is going to be the introduction. What is Delta Lake, and why is Delta Lake, why you want to use it. The part two is going to be like a deep dive, talking about the features of Delta Lake. And maybe for this part, by the way, if you have any question about the features, maybe you can just raise your hand and I will ask you. That way you can ask your question. And then the part three will be like more fun, with like a quick demo, so I can like showcase all the features of Delta Lake, and then the regular conclusion, and then a small Q&A session. So yeah, let's just first start with the regular introduction slide. So my name is Theo Lebrun. I live in New York, and I love pizza. So this is me with New York style pizza. I promise next time I will bring some New York style pizza. I know there's some people that love New York style pizza over there, so it would be cool. But yeah, I work at Ippon Technologies. We are a consulting firm. I'm a data engineer and also technical manager. And yeah, if you want to reach out to me, I have my Twitter profile, LinkedIn, and also, sorry, not LinkedIn, GitHub, and also my personal website. All right, so let's just start by talking a little bit about the past. I don't know if you ever used, Hadoop, all this ecosystem. I mean, that was created, by the way, 17 years ago. I never really had the chance to work on it, but I think it was great. It was very big advancement in the big data ecosystem. Pretty sure still maybe some people here worked on it or still working with it. But yeah, it was very big ecosystem, like a lot of components. We have HDFS obviously for the file system. We also have Yarn, MapReduce, Hive, if you want to like query your database and all that stuff with SQL. And yeah, they were like, like I said, 17 years old, pretty old. There's still, some small issues, like you cannot really look at the data directly, like you need to use, like I said, Hive or stuff like that to look at it. And also, if you want to manipulate HDFS, you need like the binaries, so Hadoop or HDFS CLI in order to just create folders, and navigate through your folder architecture. So again, I think it was amazing a long time ago, but now it's a bit, outdated, and I think it's kind of time to move on. I know there's still like a lot of companies that use Hadoop, but it's a slow burn. Hopefully, at some point, everyone's going to be able to migrate out of that. So then, more recently, kind of like a new concept was introduced, which is data lake. And the idea was like, hey, storage is very cheap. Let's just store everything. So we can have structured data, unstructured data, semi-structured data, so CSV, JSON, PDF, movies, videos, pictures, like kind of everything to be frank. And it could be like on the cloud, like on AWS S3, for example, or just on-prem on your local storage system. Well, kind of the big issue with the data lake is it can kind of quickly become like a data swamp if you don't have any like rules in place. If you're not doing any data quality and stuff, it could, like I said, really become like a total swamp, and you don't really know what's happening. You have like multiple versions of everything. For example, I know like at a company, they were like storing Parquet files, and they were like manually doing the versioning. So they were like they had all those Parquet files, and then they were like adding 1, 2, 3, 4, 5 at the end of the Parquet files. So not very ideal, like a lot of manual steps. And then I think they were doing like they had like a link that was always linking to the latest version. So obviously not ideal. And yeah, like there's if you're storing like this other concept that I kind of want to talk about is the Parquet lake, where you store everything in Parquet files. So Parquet files are like amazing. I'm not going to talk about Parquet files today, but you probably already know like all the advantages of using Parquet files. And yeah, it's okay. You can have a data lake mainly composed of Parquet files, but you're kind of like a bit limited at some point, because one of the big issues with Parquet files is they're like immutable. So every time you want to change stuff, like you want to rename columns, you want to add a new column or stuff like that, well, you have to rewrite all your Parquet files, and that's not the best. Especially if you have a lot of data, that's going to require like a lot of compute. It's going to spend time and money doing that. And also, you don't have like, kind of like basic things like ACID transactions. So, for example, if I'm like rewriting a Parquet file and the system that is doing that just shut down, Well, you're going to have like a corrupted Parquet file. Or what if, I'm like rewriting a Parquet file and at the same time someone else is like reading it? Well, same thing, it's not going to work. So, Parquet Lake, it's a cool thing. A lot of people are doing it, but you kind of want to be careful, and at some point it's not really manageable, and you kind of have to do like a lot of manual steps. So again, not ideal. And also something I just want to highlight is if you want to read your data, well, the first thing you have to do is you need to get the list of the files. So, you need to use your whatever cloud service you're using. You need to query that. You're going to get a list of Parquet files, and then you can finally read all those files. So not the best. You can, of course, if you want, manually have that list of files stored somewhere. And that's what Delta Lake is going to do for you, by the way. So we're going to talk about it later. But yeah, again, so just to recap, Data Lake, new concept. It's great, I like it, but let's just go over that and maybe use a framework that's going to solve that for you. So that framework, by the way, is Delta Lake. So Delta Lake comes with a lot of features and also like a lot of integrations. As you can see, Delta Lake, you can use Spark, Presto, Flink if you want to do some streaming, for example, Kafka, obviously. You can use Snowflake or like Redshift. By the way, I like on that picture, they don't even mention Databricks because technically Spark is Databricks, but yeah, you can also use Databricks because at the end, Delta Lake is mainly maintained by Databricks. And by the way, also Delta Lake is like fully open source. So there's obviously people from Databricks that are like contributing to Delta Lake, but there's also like people like kind of like just random people that just like the project and want to contribute to it. So that's pretty cool. So a few things you have with Delta Lake that are like awesome. First thing is the transaction log with metadata. So what it means is that every time you do operation on your Delta table, you're going to have like a log of that. So every time you create a table, you insert data, you remove data, all those things, it's going to be into your transaction log. Then we have like cool features like, for example, file skipping. What it means is, if you're querying your data, usually you query all your data and then you like filtering. But with file skipping, Delta Lake is going to be aware of like few things. For example, it's going to be aware of the minimum value of every column, the maximum value of every column, any null value and all that. So that way you can actually skip the files and depending on your query, Delta Lake is going to be smart enough to be like, hey, I already know the result of that query, so I'm not going to like query all the files and like go through them. Then of course you have like few concepts, like partition data. You just partition your data based on a column. So for example, you can partition it on a date, you can partition it like on a string or whatever column you want, and that way it's going to like create a partition for like each Parquet file. And then you have this concept that I really like. It's called Z-order. Don't really understand the name of it, but the idea is you're going to collocate the data all together in one file. So just to give you an easy example, if you have a column that is very high cardinality, you want to use Z-order because if you partition on that column, it's going to create a lot of small files, and obviously that's not ideal. So instead of partitioning the data on that column, you're going to Z-order on it. So that way it's going to be easier to query using that column. And then another feature that I want to talk about is, it's actually like a hard word to say, interoperability, which basically means that with Delta Lake, you can interact with, for example, all the libraries that we use and like, for example, pandas. We also have polars. I actually prefer polars over pandas. But you can also use Spark. You can also use PySpark or like Spark Scala, all those things. So it's very easy to like query your Delta Lake table with like all those technologies. And then the kind of like the last thing I want to talk about is deletion vectors, which is a more efficient way of handling deletes. And the idea is that when you delete stuff from your table, instead of removing, recreating the Parquet file without the data, it's simply going to create a deletion vector file. And that way, you don't touch the Parquet file. Because if you think about it, if you have a Parquet file that is like very big, every time you delete stuff from it, you have to rewrite it. And that's obviously not ideal. So instead, you're going to write into a small file, deletion vectors. And then Delta Lake is going to be able to know what data was removed. So again, this is just for like optimization. And it's really to avoid having to rewrite big Parquet files all the time. Because at the end, you kind of realize that's what use your processing power is. Like always rewriting data, you're like, hey, I want to add a new column, or I want to remove some rows, all that stuff. And you're like, okay, it's going to take 5-10 minutes because I have to rewrite the whole table. Yeah, not great. So with all those features, you're really able to do changes on your table and not have to rewrite the whole world. So now let's just take like a deeper look at what's a delta table. So at the end, a delta table is composed of two things. The data, so which is purely stored in Parquet files. So I really like that because that way, you can just query your own Parquet file. You can like look at them, with like a Parquet file viewer or like all those things. So this is very easy. Like Parquet files, it's an open format. Most people use it. Most people know about it. So this is very cool. And then, what I was talking about, the transaction log, which kind of shows you like all the transformation that you made to your table. Like, hey, I created a table, I removed some data, I had a new column, all that. And all that will be stored in the transaction log, which is, it's not like shown on the diagram, but the transaction log is actually a JSON file. So each line is going to be like all your operation, but I will show that in the demo. And then the other things that a delta table like provide, the other features, is like stuff like ACID transactions. So if you think about it, if you remember like, the Parquet file, they're like immutable. The way it works with delta is that first delta writes the Parquet file, and then when it's done, it's going to write to the transaction log. So that way, every time you're going to query your delta table, it's going to be Parquet file that actually exist, and they're not going to be touched. So that way you like avoid situation, what I was explaining earlier, where you create a Parquet file and then the system fails, and then you try to read the data and that Parquet file is like corrupted and then the whole system crash. So ACID transactions is actually a very cool feature, very good, and you definitely want to have that. Then the other cool thing is if you want to stream data or if you want to do batch data, you can actually use a delta table and you don't have to do any changes. You can do both operations on the same table, so very easy. Then we have like the DML operations, which is basically create, updates. Okay, I made a typo, it's actually delete. And you can use like any languages to do that. You can use SQL, you can use Java, Scala, or even Python. So I like it very much because no matter which language you can like interact with your delta table and do operation on it. And then the other thing I want to point out is like the scalable metadata. Well, because if you think about it, everything is stored in JSON files. At the end, it's very easy to scale. Like you're just going to create like more JSON files, and also delta lake does something under the hood is that when there's like too many transactions in a file, it just creates a checkpoint. So that way, delta lake doesn't have to read all the instruction of the file. It's just going to read the checkpoint. It's going to be aware of the state of the table. So that way, you're going to be able to have a table with like 1,000 or even like 1,000,000 operation on it, and delta lake will be able to read it without any issues. So now we kind of like have a description of what's a delta table, how it works under the hood. We have Parquet file, we have the transaction log, and all those things. We also have like I will say like the main features of a delta table, but there's actually like a lot of features that I'm going to talk about. So let's take a look at that. So the first thing I want to talk about is the schema evolution. So the first concept is a logical column name. And what it means is that the name of your column is going to be stored in the transaction log. So why is it very cool is because if I want to rename that column, well, if I had a Parquet file, I will have to recreate the whole Parquet file because, like I said, Parquet files are like immutable. Well, with Delta Lake, it's just going to rename it in the JSON. It's going to add a new line and say, hey, that column used to be called whatever, like A. Now it's called B. So very easy, very efficient. I don't have to rewrite the whole table. Same thing for like if I remove a column. Instead of regenerating my Parquet files and removing the column and all that, no, here just going to be one line in the transaction log. It's going to be like, well, this column was dropped. Great. And then you can also enforce the schema if you want. So be like, hey, you're trying to add some data, but the schema doesn't match. You can't do that. So Delta Lake will tell you like, hey, you can't add that data because you're missing this column, or like this column has a different name and all those things. You can of course disable that if you want, and then we're more like in a schema evolution scenario. And then one last thing, which is again very pure, like if you're used to SQL, you probably know about like check constraints, where it's going to be like, hey, I want to check that column. If that column is more than 10, then I don't want to add any data. So you will be able to do that with Delta Lake. So here I just want to highlight all the features that you have with Delta Lake, and all the things that I would say are pretty standard, but sometimes it's still good to remember, hey, you know what, we can still do like check constraints, or if I want to quickly remove like a column, I should be able to do that.
Got a question.
Yep.
So for the schema enforcement and the check constraints, when does that apply?
So, okay, so the schema enforcement is just to avoid adding new data to your table if it doesn't match the schema. So let's say you're missing a column or the column name is different, right? So for example, Delta Lake will tell you, hey, whatever you are trying to add to. Yeah, when you append data. And then the check constraint is the same thing when you append data or even update data. If, for example, the column has a value like more than 10, and that's like not matching, your check constraint, then the data is not going to be added. And Delta Lake will tell you, hey, you're trying to add something that is not matching the check constraint.
So it's no different from a database insert as far as it applies.
Yeah, exactly. It's when either you update or when you append data. Append or add data. All right, and then we have also two other features that, if you work on like warehouses, you probably know about: time travel. Obviously, very easy to do. You can like roll back to previous version. The cool thing is that you can actually do a select on a previous version, so that way you can know the state of the data if it was like a year ago or like 6 months ago or whatever. But if you want, you can do like a full rollback and be like, hey, you know what? We did some mistakes. Let's just go back to like 6 months ago. And then, of course, the other feature that is linked to the transaction log is the audit history. And you're just going to be able to find all the changes that were done to the table and kind of give you like an idea of what happened to the table. And then all those versions you're going to be able to like go back with time travel. But again, I'm going to show that in the demo, so that way it'll be like more clear. And then we have like two other features which are like optimize and vacuum. So the first one, I want to talk a bit more like the small file problem. When you have like Parquet file, on your storage system, usually the sweet spot is like 500 MBs. But depending on your processing power and what you're trying to achieve, that size can vary. You can go to like 1 gig or like, I don't know, more than 1 gig, it depends. But what you really want to avoid is having a lot of small files, because for your I/O, it's definitely not ideal. Like if you have, like 1,000 or like millions very small files, every time you're going to query that, it's going to read all the files and it's going to take forever. So Delta Lake comes with like a command which is called optimize, and what it will do, it will like compact everything, or other people call it like bin packing, and it will basically take all the small files and put them into a big file. So that way, you don't have to manually do that. You can of course do it, with like libraries and stuff, but it kind of like defeat the whole purpose and be like, instead of doing it manually, I can just use the optimize command right away. So a good like use case for that will be like if you're streaming data and you're like making changes, I don't know, let's say every minute, you're going to realize at the end of the day, you're going to create like a lot of small files. So at the end of the day, you can run optimize, and it's just going to group all the small files into one big one. And then we have like the vacuum command, which basically remove the history. So by default, it will keep like 7 days of history. But if you want, you can set to 0 or like, I don't know, like 2 weeks or whatever. And then it will remove basically all the Parquet files that are like older than the threshold that you set. And the whole point is that, if you want to save money, you don't want to like spend money on storage that you don't really care because you know that you're not going to go, 7 days behind, then that's fine. You can just run vacuum and it's going to remove all the Parquet files. So now I'm just going to do a small demo. So in the demo, I'm just going to do like the basic operation. So first I'm going to ingest some data. I'm going to create a Delta table. Then I'm going to like update the schema, like perform a merge, and then kind of run the utilities command like optimize and vacuum. And then I kind of want to highlight that once you have your Delta table, it's very easy to read data. And in that case, I'm going to use polars. So for the demo, I'm going to spin up simply like a Jupyter Lab notebook. And here, if you remember, to interact with Delta Lake, you can use Spark, or we will see later that if you want, you don't have to use Spark. But for the demo, I'm going to use Spark. But the cool thing is, so let me just increase a little bit the font so that way everyone can see. All right, perfect. So if you used Spark before, you're probably like, oh yeah, I'm not a big fan of Spark. You need like a Spark cluster, or you can use, I don't know, AWS EMR. You need to manage that. It's not the best. In that case, I'm actually not using any cluster. I'm just running Spark, directly on my laptop. And if you like, I don't know if that happened to you, but like me, when I was trying to play with Spark before, it was kind of like hard. You need to install like Java, Maven, configure all that. It's a bit complicated. And now, like, you can actually just, use that command over there. which basically going to configure Spark with Delta pip, and it will just like install all the necessary dependencies and all that. So that's actually very easy and very cool, and like I say, like it's way more straightforward to set up. Here you can see I have like some custom like Spark configuration, but we don't have to really go into details. But if you want, we can talk about more later. So the first thing I'm going to do, like I say, I'm just going to like configure my Spark session. So here, like I say, it's going to do everything for me. So I'm just going to scroll down, and now I have my Spark object, and everything is ready. And then if you remember, I'm just going to like read some CSV and like create a table and do all that. So let's just start by looking at the CSV itself. So here, very simple. It's basically like it's about like the Apple stock. It's every day. It's going to tell me like the close, last price, the volume, the open, the high, and the low of the stock. And this is, I think it's like, I forgot how many years, but I think it's like 10 years of data or something. So that's my CSV. Again, very simple data, nothing crazy. So here I'm going to use Spark. I'm going to read my CSV, and then I'm just going to print the data frame. Okay, so we have a data frame. Again, nothing crazy. This is just the CSV. First thing I'm going to do, classic, I would say, data engineer work. I'm going to do some, conversion, some casting, all that, so it's cleaner. So, I'm going to take my date column. I'm going to convert it to a timestamp, using that format. Then I'm going to take the volume. I'm going to cast it to an integer. And then I'm going to take my close, last, open, high, low, and I'm going to cast it to a double. So that way, because that's kind of an issue with like CSV data. There's no type, so you kind of need to manually do that conversion. So now I have my data frame, and I have my date, and all the values are like in the correct numbers. So ready to be created and added to a table. So now I'm going to create my table, and here I'm going to do some cool stuff that I actually didn't talk about in the presentation. So I'm going to create my table right here. I'm going to give it a name. I'm going to give it a location. I'm going to reuse all the columns that I defined in my data frame. So here I can just say .schema, and it's going to know like all the columns from my data frame. And here I'm going to add two new columns, year and month. And if we look at it, we actually realize that they're going to be generated from my date column. So what I'm doing is very simple. I'm like, from that date column, I'm extracting the year and the month. Of course, I could do that manually and be like, hey, before creating my table, let me add those two columns to my data frame. But in that case, I actually want Delta Lake to do it for me. So this is very cool, because that way you don't have to worry about it. And Delta Lake will just generate the data using whatever you wrote here. And then for the demo, I'm going to partition by year and month. So finally, I'm going to run that. That's going to create the table. Then I'm going to write data to the table. So here I'm going to append data to the table, right? And again, I'm just going to say, hey, save as table, and I'm going to specify the table name. And then finally, I'm just going to display the table to make sure everything was good. So let's run that. It's going to take a few seconds. And basically, what it's going to do is going to create the table and then append the data to the table and then display my table. And here you can see, we have the year and the month column with obviously, the correct values like 2016 and then, 5. And now if I take a look on my folder, we have like a new folder here, my table. So let's, dig a bit into it. If you remember, I'm like partitioning my data on year and month. So if I go to year, 2023, then I can go to month. And then here I have like, I don't think we can see because it's a big name, but we have like a Parquet file. Because if you remember, all the data for Delta Lake is stored at Parquet file. So, everything is looking good. I have my Parquet file, nothing too crazy. But if we go into my Delta log, here we have our JSON files. And if you remember, the JSON, they contain all, the history of the table. So let's take a look at it. Let's see how it renders, because, obviously this is very zoomed. But like, if you remember, each line, is an operation on my table. And here we can see, for example, that line, it has, one Parquet file. This is the path of the Parquet file. And then, we have like other value, like the partition values, 2013, 11, stuff like, the size or whatever. And then something I want to highlight is the stats column, which is, if you remember, the file skipping feature. So here we can see, for example, that we have this minimum value thing. And we can see that, hey, for the date column, this is the minimum value. For the close last, this is the minimum value. For the volume, this is the minimum value, etc. Same thing for like max values, and then same things for like null count. And if you remember, that's the file skipping feature. So that now like Delta Lake knows already that in that file, those are the min, max, and null, for like each column. So that way it already knows that. And if I do a query like, hey, give me like how many nulls for volume, it already knows, oh yeah, it's 0. So very cool, and again, file skipping. So that way, instead of looking at the whole Parquet file, it's just going to look at the transaction log. For the demo, it's maybe a bad example because it's very small Parquet files. But in real life, when you have like very big Parquet files, obviously this is better.
I have a question for you.
Yep.
So those stats are really just to help understand the min and max for what's in the file.
So it's for each column.
For each column.
Exactly, yeah.
Each file for each column.
Yeah, and the whole idea, so it's for each file because it's partitioned by file and month, so you have to generate it for each file. But the whole point is like if you do a SQL query, it's like, hey, give me the max of volume. It already knows the max of that value.
Does it also do like histograms to understand more about the distribution of the data within the file? Or is it more
it's like if you see, it's very simple. It's like min, max, and null. You can probably like add more stuff, but at some point you will have to either create a view or like either do another system that compute that, I don't know, every hour or every day. So that way you don't have to run the query that gives you that data because for like complicated things, now it's gonna have to manually look at the files and calculate that for you. Here this is pure for like min, max, and null. And also another thing is it's not going to do it on every column because that would be actually insane if you have a Parquet file with like 300 columns. I think by default it's like the first 16 columns. So you kind of want to be smart about it and put the column that you care the most at the first of the file. At the first of your Parquet file. But anyway, there's like a lot of details, and actually after the demo I'm going to show you the transaction log protocol, and it explains everything. But for the demo, let's just stay simple. So we have our table, it's created and everything. So now let's do, some operation on it. So the first thing I'm going to do an update. I want to update the schema. So here what I'm going to do, I'm just going to like filter my data. So I want all the data from like 2023 and from January. And then I'm going to add a new column, ticker. And I'm going to specify the value Apple, because if you remember, there's no ticker column right now. So what I'm going to do, basically, I'm going to add this new column Apple, but only for like 2023 and January. And then, so here I'm like building my data frame, and then I'm actually writing that data frame to my Delta table. And here, I'm doing a few things. You can see I'm using the option merge schema, so that way I'm I'm actually doing a schema evolution. And here I'm like overriding the partitions, because if you remember, the table is partitioned on year and month, so that way, it just override the data. So let's just run this query. And again, it's just gonna add, override the data for 2023 in January and add a new column. So here we can see we have our new column, ticker. Obviously, the value is null, because if we look at the date, this is not, January 2023, sorry. But if I run the query again and I use my filter, then we're going to have the ticker column, and we're going to have Apple like what we want. So again, here, this is just to showcase the schema evolution, and that if you add a new column, whatever it has before, it's just going to add null. Now we're going to do a merge. A merge is a bit more complicated, but if you're familiar with SQL, this is basically an upsert. So we're either going to update the data if it's already exists, or if it does not exist, it's just going to insert it. Here, what we're going to do, we're going to reuse our data frame. So remember our data frame, this one from like January 2023. We're going to set the volume to 0, okay? And then we're going to merge that with our table. And what we're going to use for the key is date, because if you think about it, the date is our primary key. Again, this is not a real primary key, but it's really, for the demo purpose. And then we're going to say, hey, if you don't match it, you're going to insert. So that's the insert part of the upsert. And then if you match it, you're just going to update. And then, finally, I'm just going to show my table. Again, with the filter, because, we don't want to see everything else. And here you can see volume is equal to 0. So, the merge was processed correctly. So now that we did a few operations on my table, let's just take a look at the history. And here, if I run history, you can see that I have 4 versions. In order to make it easier, I'm just going to run that query which basically going to select, only a specific set of columns, because there's some columns we don't really care, like user ID, username, all that. So here we can see we have like 4 versions. First version is, create table. That's when we create our table. Then we have our first write. That's when we wrote the data. Then we have a create or replace table as select. That's, if you remember, that's when we introduced the new column ticker. And then we have our merge. So, again, very easy to see all the operation, what that was done on the table. And now we can do cool stuff. So now we can be like, you know what, the merge, we don't really want it. That's not great. So let's just, show me the data, what it was for version 1, so for this version. So here you can see I can do the same thing. I can read my delta table. I can specify the version number, so in that case 1, which is, this version over there. And then I'm going to load my table like usual. And then, just for the demo, I'm just going to, again, apply the same filter, so, 2023 and then January. And here what it's going to do is going to show me the data before we added the column ticker. So, like it used to look, I don't know, like 7 minutes ago. If you want, you can also do a restore. We're not going to do that, but if you're like, you know what, this is crap, I want to go back to my version 1. So the whole table is going to basically go back to the version 1. So again, it's just to showcase how easy it is to, to do a rollback or like just select the data that how it used to look like and all those things. And also something I want to highlight is here I'm using a version as of, but you can also use a timestamp. You can be like, hey, give me the status of the data, how it was like, 10 minutes ago. And Delta Lake would be smart enough to be like, oh yeah, 10 minutes ago, that's like version 1 or like version 0. So again, very easy to do time travel and all those things. Then we have the common vacuum. So if we take a look at our Parquet files, oops, let's go. So again, same partition, 2023 and then January. We have 3 Parquet files. Well, if you think about it, sorry, it makes sense. The first one is when we created the table. When we added the data to the table. The second one is when we introduced the new column ticker. And then the third one is when we did the merge. So now I'm like, yeah, you know what? This is taking a lot of space. I want to remove all that data. So let me run a vacuum. And if you remember, vacuum basically going to remove all the data that is like older than what you specify. And for us, I'm going to do 0, which is basically 0 hours. So what it's going to do, it's going to basically remove the two files, the 2 oldest files, so this one and this one, because now we only care about the latest version. So the vacuum, it takes few seconds, and then at the end, it's going to tell me, hey, I removed 2 files, and then if we look at it here, now we only have the Parquet file, which is, the latest version. All right, so oops, looks like I lost it. Then here, I just want to highlight a few things about file skipping again. If we take a look at the explain plane, here, when we do the query, we will filter common. Remember, 2023 January. You can see here it's using the partition filters, and it's specifying, hey, when you create that table, you only care about the partition 2023 and the month equal 1. So that way, Delta Lake knows that it only has to read those files. It doesn't have to read all the files and then filter by year and month. Here, by using these partition filters, it's only going to read 1 file. So, very efficient, and it's going to skip all the files. But the cool thing is, if you remember, the year and month column were created based on the date column. So here, I just want to highlight that if I use the same query, but instead of using year and month, I'm going to use the date column and say like, hey, give me the data between those 2 dates. Well, Delta Lake is also going to be smart enough to be like, hey, if we look at the partition filters, you can see that it's doing the logic for me because it knows that the column year and month were generated from the date column. So this is pretty cool. You don't have to manually use the generated columns. You can directly use whatever column we use to be generated on. And now, just to finish the demo, I want to showcase that if you want, you can also just read the data directly with Polars instead of Spark. So here, for example, I'm going to use Polars. If you're not familiar with Polars, it's like pandas. It's very similar. And I just want to showcase that you don't need Spark. You don't need you just need Python and in that case Polars. And here we're going to be like, hey, this is my delta table. Here I'm going to specify, my partitions if I want, so 2023 and month. You can see that I'm not a big fan because you manually need to specify those partitions. But again, this is just for the demo. I just want to showcase that it's working like that. And here it's gonna just run the query. I mean, there's no query. It's just reading the data, and it's gonna return me the data. And again, I just want to highlight that here we didn't use any Spark or anything. We're just using polars, so that's pretty cool. Now something I want to show again. If we go back to if we go back to the history, if you remember, we run vacuum. So you can see here we have a vacuum start and vacuum end. And if you remember, the two files were removed. So what happened if we select a version that was actually using those files? So for example, version number 1. Well, let's see. So if I go back to the end, let's use version 2 as the same. So here I'm using polars, and the cool thing with polars, you can also specify a version. Well, it's not going to work, because if you think about it, the Parquet file was removed, right? And here, if we scroll down, you can see it saying, hey, the Parquet file was not found, which makes sense because we run a vacuum with 0 hours, so it basically removed all the data that was like older than 0 hours. So, just want to showcase that Delta Lake will throw errors at you if you try to read a version that is not saved anymore. So that's pretty much for the demo. Let's go back to the presentation. Yeah.
What happens if you change the partition?
So if you add the colon or remove a colon?
Just say you had a partition on
month and year, yeah.
What if you wanted to partition
a different column? Yeah, that's going to be a full rewrite. Yeah, unfortunately, if you think about it, you cannot really avoid that because, so yeah. That's why a partition strategy is very important, and I've seen many times where people don't partition their data in the right way, and then they regret it later. Yeah, sorry, go ahead. You can go, sorry.
Oh, I was going to ask, I always see the delta replace where strategy brought up.
Yeah.
And my brain can't understand how it's different from insert overwrite. Is that something that you could
Yeah, let's take a look.
afterwards?
I know, I kind of skipped that part. Oh, yeah. So, sorry, I got to repeat. So the question was, what is the purpose of replace where when we're doing a merge or other operation? So here, this is, you mean this one?
There's
the replace where?
As a merge strategy, there's insert overwrite, but there's also a replace where, which is supposed to be performant, and every time I read the two things, they sound exactly the same to me.
No, not this, because this is not for the merge. So I think you meant, because, I have...
It might just be a SQL API thing.
Yeah, because, so there's something maybe I want to talk about, which actually, because, when you replace that's a good question. When you replace, we can talk about that. So the replace where is when you replace the data, you can choose to basically overwrite the partitions, and that's where you're going to use the replace where. And here what we're saying is instead of specifying replace where and providing all the partitions, you can just say, hey, partition overwrite mode dynamic. And what it means is that whatever data I'm going to overwrite is just going to replace every partition with that. But if you do the replace where, you have to basically manually specify the partitions. So in that case, I'm using the partition 2023 and month 1, so I would have to use that instead. I used to do the replace where, but now with the dynamic partition override mode, I don't have to worry about it. The only issue is, it's going to replace everything that with the new data. So if you make a mistake, you might lose some data. But anyway, sorry, go ahead.
So does this work with your ML libraries, the same type of data structure?
So it depends, so what kind of ML framework, if you like, it depends, your ML framework. If you if you work with Parquet files, you can just get the list of Parquet files and then inject it with your ML framework. But if most of the I know MLflow, for example, that will work out of the box, but you just need to take a look at, but at the end, like I said, it's Parquet files. So what you want to do is just grab the list of Parquet files that actually from the latest version and then use that with your ML framework. Sorry, go ahead.
From a security perspective, is that handled from whatever's sitting on top of your Delta Lake if I want a developer to be able to read from the Parquet files but not do any of this replace or overwrite?
So that's a good question. So in terms of security, how do you handle, do you do raw access level, file access level? So if you think about it, Parquet file, sitting on S3 or whatever. So whatever, like let's say you give access to like a notebook, whatever the notebook is going to have access to, the person is going to be able to read the data. So it's, you cannot really do like by file. I mean, you can try to do by file, but it's going to be a lot of work, right? If you want to control, hey, you only have access to that file and that file. So most of the time, you either have access to all the data or you don't have access at all, right? It's kind of hard to do like by file level. And by row level, no, it's not possible. Or what you can do by row level, but this is a bit advanced, you need to do a view. And then, you will be able, you generate the view, and then the view will like return whatever rows and filter out what you don't have access to. So that way, based on your user, you might have access to, some rows, while someone else is going to have access to everything. But again, this is more manual work because you need to create the view, you need to create the rows and all that stuff. All right. You have a question? Sorry.
Do you have the ability to create calculated columns with this?
To create what?
A calculated column, like if you wanted to take the difference between the high and the low.
So like a generated columns? Mm-hmm. Yeah, absolutely. So if you go back to generated columns, you can, just put whatever SQL, not function, but like, I don't know, like operation as you want. So if you want to do like, hey, this column multiplied by this column minus this column, yeah, you could absolutely do it. And here, if you see, we're even using like SQL functions. So, you can do, for example, current date minus the year or whatever. So yeah, that will work on the fly with a generated app.
If you restore back to a previous version, in the change log, does that show up as an additional?
Yeah.
Right?
That's a good question. Yeah, actually, like maybe let me try to show you. That's why, by the way, that's why it was commented because I kind of wanted to do it. So let's play around with that. So for example, here, if we try, like, let's try to go back to version 3. So I'm just gonna what? And hopefully it's gonna work because I didn't try it. All right. Then if we show again the history, yeah, you can see here you have a restore. And actually, let me show.
Do the more detail, does it show you?
It will show you the version. Yeah, absolutely. Yeah, you see here, I kind of skipped that part, but you see here it tells you which version you used. There's actually a lot of other cool things. Like here it tells you the number of files. When we created the data, it basically created 121 files. When we added the new column, it created one file. So yeah, you have like a lot of metrics that I didn't show, but of course you have access to. All right, so that's pretty much it for the demo.
I have a question.
Chris, go ahead.
I'm sorry in advance.
Don't be.
Yeah, so when you're making all of the changes, and the changes are in a change log, right?
Yeah.
From a time travel standpoint, there's a copy that exists, right? Does that copy need to live? And maybe I'm not understanding it from like how everything is laid out. Does that copy need to live in the same place that it always
Yes.
has? Or can I move it to cold storage because it's a little bit cheaper?
Yeah, it's cheaper.
Storage is cheap until it's not, right?
Yeah. No, so for the history, the data needs to be at the same position.
Okay.
So I guess you can trick it and manually re-put all the files with the same name, but that sounds like a crazy amount of work. So I would not recommend to do that. Okay. But yeah, no, it has to be at the same position. If you're doing cold storage, what you can do is you can, like let's say for S3, you can have like a lifecycle policy. So then it just moved to like Glacier or something. And yeah, as long as no one query with that version, you're fine. And the day you want to restore, you just
you have to move it back.
Yeah, you will have to change the storage setting to come from Glacier to like regular S3. But yeah.
Slightly complicated.
Yeah. Oh yeah. No. Absolutely. Yeah. No. At this point, it might just be easier to, I don't know, just put everything into a Parquet file somewhere else. But yeah. But the good thing is they kind of like Delta Lake. They kind of recommend always. Like let's say, hey, I don't like that table. I want to create a new one. So usually I'm just gonna like remove the folder and start from scratch. But they actually recommend no, it's fine. Just keep doing stuff on it. It's fine. At the end, it's just files. Like it's not gonna impact. But maybe one issue is that your transaction log is going to be like a lot of operation, and maybe you don't really care about the last, whatever happens after version 10. So it really depends of your use case. But yeah.
It's like the same question.
Okay.
Is there a way to configure like a vacuum to move the file somewhere else, or
No, vacuum, just remove them from your file system, yeah. No, you
Manually move them
yeah.
back, keep that for certain.
Yeah. So yeah, question.
Have you seen a use case for time travel besides like, oh, we made a mistake and we have to roll back?
Mm-hmm.
Like what, yeah, because I've used it before, but the only situation I've used time travel was like, oh, our data got messed up, we have to like revert.
Yeah.
And we only saved like 7 days worth.
Okay. I mean, it depends of, I would say, your use case and all those things, but I definitely seen situation where, even me, like I did an operation, took like a few hours to run, and then I realized it was wrong, and I was very happy to, roll back and be like, I don't have to worry about it. No one saw it. No one told, no one, what I'm saying? Like, I didn't, so it's fine. So yeah, I've seen that. I've also seen some situation where you query the data in the past because you're like, wait a minute, what was the value of that column like, 6 weeks ago? So that's actually very cool. But I think maybe it looks super fancy and maybe I kind of agree with you, you don't really use it, but when it's there, you're happy it's there, because having to, start again, you're just like, whoa. So I've seen a situation, but again, this is a very edge case where basically the table got corrupted, got broken, and it was just like, I don't know exactly what happened, but I didn't want to know, to be frank, and I was just able to revert. Oh yeah, so I remember. Okay, there was another situation, but it was very funny. Basically, it was recreating a table on top of it, but with a select 0, so with no data. So you had like a table with like millions of rows, and the next day there were no data. And everyone was like, what happened? And I'm like, oh, just roll back, it's fine, no one like, it's okay. And I was very happy to see that. And at the end, I forgot exactly why, but it was just funny that the whole table just got wiped. So.
The use case is like the auto expiration, I forget what it's called.
Yeah.
So like you vacuum it.
Exactly, yeah, you vacuum, yeah.
Also like an insurance policy,
Yeah.
or like a feature to say,
Yep.
if we run vacuum once a week, and anything that's outside of like the expiration policy is just gone.
Yep. Yeah, I mean, at the end, it's really like, do we actually care about having data from like a while back? And most of the time, not really, but yeah, very good.
Can you use the time travel to replace like a traditional slowly changing dimension?
Oh, like SCD?
Yeah, where you can maintain that SCD table and keep the change log.
Yeah. So it's funny because Delta Lake actually support SCD. You can you can use it and everything, but yeah, with SCD, I think it's a very specific case. So in my, I guess it depends what type of SCD you're doing, if it's like type 1, 2, 3, or whatever. But in my case, we were like storing, the last date, basically, of whatever run was done. So by reverting back to, let's say, 2 weeks ago, we had to process 2 weeks worth of data, and that was actually like a lot of things, right? Because of the whole SCD process. So, I've done it, but it was for like, very short amount of time. Because if you have to reprocess the whole data from scratch, depending on your data, your table size, it might take a long time. So, yeah. But I've definitely done it with like SCD, yeah.
So I just want to say one more thing before we wrap up, or is there more to your presentation?
Yeah, we just have like one last slide. That's fine. I'm going to go fast because we're like almost out of time. But I just want to kind of talk about the whole Delta Lake ecosystem. So I talked about polars. Again, if you're using pandas, nothing's wrong with that, but it's actually better to use polars, and for multiple reasons. And a reason that I really like is because of the scan function. And I don't know if when I used pandas before, and when you try to load a very big CSV, you probably run into memory exception. Well, with polars, what you can do a scan, and what it does, it basically lazy load the data. So that way you can have filters, and then when you execute your query, it's just going to return the result. Instead of pandas just load the whole CSV in memory, and then, depending on the size of it, might explode. So definitely, I'd rather use polars instead. And here, I just want to showcase, with polars, you can, scan delta, like I say, if you want a lazy read, or you can just read delta like we did in the demo. And you can even write to a delta table if you want. So the great thing with that, you don't have to use Spark. So no need to have a Spark cluster and all that. Then we also have Python Delta Lake and Rust Delta Lake. I'm not going to go on the website, it's fine. But the idea is that we have a Rust implementation of Delta Lake. So that way, if you don't want to rely on Spark, you can just use Rust. the Rust Delta Lake package. Then we also have delta sharing. That's if you want to share data, with other people. So you're going to have like a delta sharing server, and then you'll be able to like share, your delta table. Then we have the protocol. I forgot who had a question about like the specification. Here, this is the whole delta transaction log protocol. It's big, so definitely. I would say just focus on what you want to know, or if you're courageous, you can just read the whole file. But it basically defines everything. So for example, like check constraint, it's going to tell you like, hey, this is how check constraint works. So again, it might give you a headache, so be careful. And then of course we have the Delta Lake website, but I don't think I need to show that. But it's just delta.io. So yeah, I just wanted to say thank you for your time. Of course, I would love to chat more. I know we had like a lot of questions, so I'm available. So if you want to chat with me, I will be around for like the next hour. Of course, about Delta Lake, but like any other technology. And you can also like email me at Theo Lebrun at Ippon USA. Thank you.
So much for continuing to build this community. Today, there were so many people that signed up, so many people that came. And today we get to learn about like dimensions and time travel and swamps and some constraints. Like it's been fun and interesting. And so the key in all this is the community. The fact that we have some recruiters, some people looking to hire people, looking to staff people, looking to look for jobs, looking to skill up. It's like so cool. And we listened to these this one was a really cool topic, this Delta Lake. Yeah, let's give it up. This was a cool topic.
Thank you.
So I'm like, but this is super valuable. So like, I just fell in love with it. So just want to reemphasize this is the Data Enthusiasts. Really emphasizing the community. Like we're a community, and like all of us kept coming out. We got pizza. Now, the sponsors. Roman usually sponsors the food and the beer, so that's amazing. However, we are finally opening ourselves up to sponsors. I have told a lot of people no, and before it was like, okay, we have to have an order and stuff, because I've already had people ask, and I feel bad telling one person just because they're the person that we talked to last right before we pushed the meetup button. The opportunities, the way the sponsorship works is basically you would buy the food, or we can be a little bit more flexible. The benefits are you get visibility. We're still figuring out that, but it's pretty much probably going to be like a 5-minute or a 3-minute or something spiel. It could be good for a recruiter. It could be like even if you're looking for a job, you might be able to just yap for 5 minutes with a good crowd. That might be exciting, or you might be on the consulting side, or you might be on the, hey, we're looking for people side. So I think there's a lot of cool slices, but I mean, Roman's been nice and awesome. Like I do the meetup thing, Roman does the food, but the food is like complicated. It's not just like, it's like logistics of bringing it there, and then who's gonna do all that stuff, and then also at some point we maybe, locate, like everything's up in the air. Like if you're like, hey, come use my office, we can change up the location one here and now. Like there's a lot of things. We're going to be doing more happy hours, blah, blah, blah. Thank you guys so much, and hope to see everybody next time. Thanks, everybody.